Let's see, got it. And then there was something else I had to do. If I hear that echo, I think I know what to do. No. Let's
Yeah,
see, let me pause that. I think the main thing is I gotta pause it there. Okay, so, and let's just start here. Okay. So, like, okay, so I was trying to get to this point where I'm live streaming, so that way, if I decide to use this for another class, I can, and that way you have it on record. So I wanted to kind of let you guys know that I do live stream these recordings. So if you actually are subscribed to my YouTube, like I think I just got my notification. If you subscribe to my YouTube with your notifications turned on, you'll know when I'm going live at least, and that's important because sometimes like students ask questions about the homework, and I'll just put, hey, this is how we work through this question, and like you just want to know what I'm posting, not that you have to necessarily watch everything, but like when I post videos and lectures and things of that nature. So you definitely want to be subscribed to my YouTube channel with your notifications turned on. And then that's just how we're going to communicate for this semester. Now, after this semester, you can always stay subscribed and just turn your notifications off. It's just like a thank you throughout the whatever time. So I wanted you to be aware of that. I am live streaming these on YouTube, but I try to keep your information as I try to keep sensitive information as private as possible. So I'm trying not to. I intentionally go out of my way to not say names, not to show names and things of that nature as best I can. But so that's one thing. So this is like week two. Obviously, we lost. No, we didn't lose a day because we only meet on Wednesdays and Fridays. Um, so now I do expect that you have already watched the lecture for section 2.5. I try to get up there with enough time for you to watch it beforehand. You should also have access to like the blank notes and the worked out notes, right? So now today, I usually do a poll. Let me see if I can, how quickly I can do this poll. I'm gonna hit done because I think I have to interact. It says that it's live. So let me do a poll real quick. What would you like to do today? Go through the homework questions or go through the lecture? That's the same one. We can do it. So I just launched a poll, right? So I like to give you all a choice. Which option do you want? Would you rather go through the homework for section 2.5 or would you rather go through the lecture for section 2.5? 2.5 is covering rational functions. So that involves a lot of factoring. So it's a pretty big review on it's a decent review on factoring and some other notions. Oh, we are neck and neck. We need a tiebreaker. Okay, we got it. Okay, it's updating. Okay, so I think majority would like to go through the homework. So we're going to take some time to go through as many homework questions as we can. Now, we don't necessarily have to stick with 2.5. Honestly, the intent is again, we only have 50 minutes. And today, if we get out at 10:50 and it's already 10:20, there's only like about 30 minutes left in class, right? So obviously that's not enough time for us to like sit down and go through a whole bunch of stuff. So that's why I do everything asynchronous, where I load the lectures separately. I expect you to kind of watch those on your own, take notes on your own, work on your homework. And the idea is to use class time as a study session. So you can ask questions, we can go through specific questions. We don't have to do, let me get the student. Yeah. Okay. We don't have to, can I just close it? We don't have to like do it specifically what I'm doing. Let me check the chat real quick. I just kind of go through as many questions until people have specific questions. So if you would like me to go through a question in particular, just stop me, and we can do that. So, but if there aren't specific questions, then I'll just make my way through as many homework questions as I can, and we can start here actually. Let me see. This is okay, but let me do this. I think if I go like, there it is. Get some zoom. Okay. So again, so this is section 2.5 over rational functions. Again, I'm going to go through this assuming that you've watched the lecture already and you've taken notes, and we'll try to get through as many of these questions as we can. Now, one thing I do want to kind of bring to your attention as you're working through these assignments on your own, again, my recommendation, do what you can on your own using your own research and Pearson and whatever resources you have access to. Once you've done what you can on your own, from there you want to definitely link up with at least 3 of your classmates. I know that some of my other classes had group meets going. I don't know if y'all already started that or not, is I encourage it. I recommend it. I think it's a good thing. Y'all need to learn how to work together. It's important, right? It's okay. So I try to design it centered around you guys working together, and it's okay. So do what you can on your own. Work with your classmates. Once you and your classmates have done what you can do, next level plan of attack is you definitely want to link up with the tutors. Hopefully, you've already sought out the tutors. You know the schedules. You know how to find them. You know how to contact them. Things of this nature, right? So that's important. Once you've exhausted those three sources, then that's the best time to come to me. You can come to me first, but then oftentimes my experience is that students are overwhelmed by my presentation. But once you've thought about it, you've been frustrated a little bit, just a little bit, you've done what you can with your classmates and the tutors, then when I give the exact same presentation, I can see the light bulbs going off a lot better. And it's just a better experience for not only me and the students, it's a better experience for everybody. So that's one thing. So then the other thing I wanted to mention, so now I don't know if you're familiar with Pearson or not, but Pearson is a great learning aid for, like, as you work through these questions, suppose you're stuck, you definitely want to make use of this get more help, right? That tool is why I vouch for Pearson, because honestly, on Pearson, when you're working your way through the homework, every question comes with an explanation. Like they pretty much explain to you like the reasoning and logic behind the question, and you can get as many attempts as you like. So help me solve this. I don't really recommend that tool. It's something weird about it. Like you don't get the credit. It's something weird there. I don't really recommend that. View an example is the one that I usually recommend. You see a written explanation. Sometimes they're a little bit, not clear, but still you do have at least an explanation. You can sit down with either your classmates or the tutors and go through that, or me. And then a lot of the questions come with a video tutorial. You have a copy of the digital textbook with the e-textbook there that you see. And then another powerful tool is to ask my instructor. Now, I'm not gonna lie, I do struggle with checking my emails because when I'm not with you guys, I'll be ripping and running the streets, just trying to, survive basically. So it's okay to send me emails. It's just, it's a good chance that I probably won't respond quickly. But so like if I don't respond to the email promptly, then just ask me next time we meet, right? That's what I recommend. It's like send it in the email just to have it on record. But if we meet again and I haven't responded to your email, just ask me during class. And I can do like a private session. So it's just me, like if you need to talk one-on-one, we can, and I won't stream those. I'll like stop the stream and like we'll go one-on-one if we need to. But the Ask My Instructor is a powerful tool because it'll basically send a screenshot of your specific question to my device. I'll load it, make a video response, load it to YouTube, and send you the link, right? So I just wanted to kind of inform you about those concepts and techniques. And the sooner you kind of start, again, working together with your classmates and the tutors and asking me questions and making use of the tools of Pearson, one of those routes, something should click, right? Okay, so with that, let's take some time and let's look at this question. We're asked to find the domain of a rational function, okay? So now there are three main types of questions that we kind of come across in this course. One of them is the rational function, right? And so whenever you ask the domain of a rational function, the rational function is basically a function that it's like you have a polynomial on top and a polynomial on bottom. It basically takes on the shape of a fraction where you have variables in the top or bottom of the fraction. Generally speaking, the domain of a rational function is all reals except, can somebody tell me except what do we have to throw out in this case? So if you think about a fraction, what's the thing with fractions that you cannot do? Mute yourself. Good question. With fractions, right? Let me see this. Let me see the other thing. The concept with this experience, whoever does the most talking does the most learning, right? If I'm doing all the talking, that means I'm the only one that's really getting it. If you want a confirmation or you want to actually do better in this, you got to speak up. A closed mouth don't get fed. So if you're mute all the time, then when you're silent, that's called like acquiescing. And it's like when people basically take liberties because other people don't say anything. So if you don't say anything, then I'm just going to keep moving. And if I start assuming that you know it when I know good and well that you don't, well, I don't really know that. But if you don't say anything, that's not a good position to be in, because then what happens is, and I'm gonna just kind of keep delaying and wasting your time until somebody answers the question. But you know, and I'm trying not to waste your time, but because you pay for this. But again, it's important. It's important to speak up. Like you don't want to be mute. And again, I can't make you. But again, if I'm answering it, if I'm saying it, that means I get it, but I already got it. So it's not for me. So again, it's okay. So again, so in general, the domain of a rational function is going to be all reals except any x that makes the denominator zero, right? So we got to throw out any x that makes the denominator zero. Namely, we got to throw out -1. So the only one that throws out -1 is going to be a, right? Okay, so I'm just going to go with that, and I'm going to keep moving. And again, it's important that you speak up because again, whoever does all the talking, that's who's doing the learning. Let me check the chat real quick. I know you guys can unmute yourself because you did it a minute ago. So then here we're asked to find a domain. Again, this is the same thing, right? So the domain of a rational function is going to be all reals except any x that makes the denominator zero. So what we want to do here is set the denominator to zero and solve, right? So now if we're looking at this denominator, let's go like this. If we're looking at this denominator, right? If we set it equal to zero, if you think about just the denominator by itself, right? If you think about that graph, that graph, that graph is going to be a parabola. It's going to be a U-shaped curve, but then we added a +6 outside the basic function, right? So then what that's going to do is take the parabola and move it up 6 units. So then where will that be zero? In other words, where will that cross the x-axis? If we take a U-shaped curve and move it up 6 units, it never crosses the x-axis, right? So in other words, the denominator in this case will never be zero for all real numbers. So then we don't throw out any x's. So then this domain is going to be all reals. So negative infinity to infinity. So then what we're going to do, negative infinity to infinity. Right? And you got to stop me if I need to go back or anything like that. If you don't stop me, my rhythm is kind of like, it is what it is. And it's a recording, so
Wait, can you explain again exactly how you got that again? Because I just
hang tight. Let me get the student. Okay, let's back up. Save. The delay. Anyway, okay. Hit next and edit. Okay. So let's hop back. Okay, and then we can go here. All right. So to kind of recap, for a rational, again, it says find the domain of the rational function. In general, generally speaking, the domain of a rational function is all reals except any x that makes the denominator zero, right? So like, for instance, if we set the denominator equal to zero and solve, if we write v squared plus 6 equals 0, and if you try to solve that, you won't be able to solve it. Because if you have v squared plus 6 equals 0, if you subtract 6 on both sides, you get a negative on the right-hand side. When you go to take the square root, you're going to be taking the square root of a negative, right? So that means there's no solution. There's no v that's going to make the denominator 0. So because there's no v that's going to make the denominator 0, then there's no v that we need to get rid of. There's no v to throw out. So then that's why it's just all reals, right? That's the long and short of that. That's I don't know any other kind of way to say it. Let's try another one. And I think the next one we might need to write. I know we haven't been writing, we just kind of been chatting. So here,
Professor, sorry, it's Amari. I just want to say I'm sorry that I'm late.
Okay. So here we're actually finding, again, the domain of the rational. Yeah, and I gave you attendance credit. So usually if I don't give you attendance credit, I'll say something, but usually I do. It's not a big deal. So again, find the domain of the rational expression, right? Again, the domain of a rational expression, generally speaking, is all reals except any x that makes the denominator 0. So here, we need to set the denominator equal to 0 and solve. Let's write this one out. We got x squared. Let me think about it. Let's do like this. I just want this. That's fine. Take that. Come on, and drop it here. kind of frustrating, but that's okay. So find the domain of the rational function. So again, generally speaking, the domain is all reals except any x that makes the denominator 0. So then what we're going to do is set the denominator here. Let's write it like this. We're going to set the denominator, which is our d of x. We're going to set that equal to 0 and solve, right? So then that's going to be x squared plus 2x minus 24 equals 0. Right? We just set the denominator equal to 0 and solve, right? So then from here, with this being college algebra 2, we do expect that you're comfortable with factoring. Now, realistically speaking, I know that most students are not comfortable with factoring, but it's just one of those things you haven't escaped it yet, right? It's not. Maybe after this class, you might see it maybe 2 more times in your life. Like, only other time I can really see you using it or seeing it if you're trying to avoid it is like if you go to apply for a job and they might give you an exam, right? A math exam. That happens a lot. That's the main thing. Now, if you're like not a math person, that's okay. You know, it's, you know, I have a whole philosophy about that whole thing. But now we have a trinomial, right? We have 3 terms, 1, 2, 3, right? So if we're going to factor this, we have x and x. Can anybody tell me something about what should the signs be? Should they be like both positive, both negative, one positive, one negative? Right. What makes you say a positive and a negative?
Because the 2x is positive, so it'd be like positive 6 and negative 4. No, negative negative 4, right?
Okay. Let me see. Give me a color.
A color? Red.
Red.
Red. Okay. Red. Okay. I heard a positive 6 and a negative 4. Okay. So let's look at this. So when factoring a trinomial, this is trinomial because we have 3 terms. The second term, second term tells you whether they're the same or different, right? If the second sign is negative, that means that these two have to be opposites. All right, let's say that one more time. If the second sign is negative, these two have to be opposite signs. What do you think happens if this sign were positive? What could you tell me about these signs? If negative means they have to be opposite, then what do you think positive means in that space?
They're the same.
Yeah, right. So if we start with the second sign, right? If negative means that these two have to be opposite, then if this sign were plus, these two would have to be the same, right? So then this first sign tells us the sign of the larger number, right? So I think I'm confident in this answer. I was just trying to get to the bottom, to get to the reason of why, right? So again, the second one tells you whether they're the same or different. This one, the first sign tells you the sign of the larger number, right? So our larger number was a 6, it's positive. So now the main thing is we're looking for 2 numbers that multiply to give us negative 24 and add to give us positive 2, all right? Notice that 6 times negative 4 is negative 24, so that checks out. And then 6 plus a negative 4 is a positive 2. So those 2 numbers were decent. That's one way of looking at it. I know some students use like this box method or X method. We'll talk about it a little bit later when it pops up, because there's another. I use that a little bit differently. But and then just as a quick check, you would FOIL out. So FOIL is like first, outer, inner, and then last. You would just multiply those, and you should combine like terms, and you should get like here, right? So then from here, now that we've got it completely factored, and if you're not comfortable factoring, I do have like some exercises, like a whole chapter on Blackboard, like in our box folder. There's a whole chapter devoted to all the factoring scenarios. I would encourage you to like make your way through it, sit down with the tutors, and just go through that chapter together. And it pretty much explains like all the scenarios that you'll come across for our class for the most part. Like I would say at least 90% of the scenarios that you'll come across for factoring. So now from here, we use a property that's called the zero factor property. When we have two or more things that multiply to give us zero, then basically we just set each thing to zero and solve, right? Because if the first thing is zero, zero times anything, then everything is going to collapse to zero. If the second thing is zero, zero times anything is zero, so the whole thing's going to collapse to zero, right? So that's the idea behind the zero factor property. When things multiply to give us zero, you basically set each product to zero, and then you solve those corresponding equations, right? So then if we apply that here, all we're doing is saying x plus 6 equals 0 or x minus 4 equals 0. If we solve these, we get x equals -6 or x equals 4, right? Right. So then what we're saying is if we plug in -6 or 4 into that denominator, it's going to produce both of those are going to produce zeros in the denominator. So when we're considering the domain of this rational function, we can use any real number except these two because these two produce zeros in the denominator, right? So we want to capture all the real numbers except these two. So what I'm going to do, these two on, just put them on a number line. They don't have to be perfectly drawn out, but it is a good idea to at least put them in order. So -6 is to the left and 4 is to the right, right? Again, these produce zeros in the denominator. So we want to capture every number except these two. The zeros are fine. So what we want basically like all of these numbers, and going off to the far left, we want all of these numbers in between the -6 and the 4, and we want all these numbers going to the right of 4 and off to the far right. So then only other thing that we need proper grouping symbols. Can anybody identify or tell me what's the proper grouping symbol? And to make it simple, I'll give you a 33% chance. Is it a parenthesis? Is it a square bracket or a curly bracket? And why? It's not about the right answer. Math is about why is that the right answer. All
I
right?
remember when it's an open circle as compared to a closed circle, that's why it matters. So it got two open circles, right? So I think that's I want to say open circle. It's either brackets or parentheses.
Okay.
I think it's parentheses though.
Okay. I see your reasoning, right? So, okay. And actually, yeah, I think you're good, right? You said parentheses is good, right? So parentheses, what in this context, parentheses means that we get close to that thing, but we never actually reach it, right? Whereas a square bracket means we get close to that thing and we actually do reach it, right? And curly bracket means just that specific number, right? So what he said was correct. Even though I was using an open circle, I was using it for a 0, but what he said was actually correct. We don't want to include the -4 and 6, so we're gonna use parentheses, right? So what the parentheses in this context means is that we get really close to -6 on the left and the right, but we don't include the -6. We get really close to the 4 on the left and the right, but we don't include the number 4, right? So then once you kind of have an image like this, now it's kind of like easy to translate it to interval notation. This line here, this is kind of like what we call set notation. I'll label it here. This is what we call set notation. This is like the graph. This is a graphical representation. And then this last part that we're going to do is our interval notation. I know we're eating up a lot of time, but I'm just trying to fill in like as many concepts as I can. It's not about the answer. It's about we need to know why we're choosing what we're choosing. That's what a lot of this stuff is about. So it's not, we could get the answers quickly, but that's not what we're doing right now. So now if we're translating this graph to interval notation, we'll get the following. So the far left is -infinity up to -6. And then we want to capture all the numbers from -6 to 4. Then we want to capture all the numbers from 4 to positive infinity. What kind of grouping symbol does infinity always get? Do we ever reach infinity? As like humans, can we actually reach infinity all the way? So that's a no, right? So we don't ever reach infinity. So because we don't reach it, it gets a parentheses. Infinity always gets parentheses for our context, right? So in this, and just because we're almost out of time, the -6 and the 4, they're going to get parentheses in this context as well, right? Because the parentheses, again, they mean we get really, 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 really close to those numbers, but we never reach it. So then we group all of these 3 different sets. We group them with this symbol called union. It basically means, you say take that first set, combine it with the second set, combine it with the third set. So any numbers from any of these 3 sets, you can plug it into the original and you'll produce a real value. But we just cannot plug in the -6 and the 4. Okay. So that was the backstory on, and again, all of these mathematical things, these are just stories, right? These are just stories. But if you don't ever nobody's ever told you the story, or if you don't get the concept behind the story, then that's where a lot of the anxiety and fear from with math. So it's just a matter of learning the story. It's just a language, and this is just like a literature class. That's what this is. It's just in terms of symbols and numbers, but you just have to learn the stories, and then they come alive, right? So you should see. I think we got what C. Let's check that one. Let's do. We got a solid 5 minutes. Let's try to get another one in there. Use the graph of the rational function to complete the following statement. Okay, as x approaches 3 from the right, so now we got this weird plus thing in there, right? So that plus in the upper right-hand corner, that means as we approach 3 coming from the right. So if we look at the graph, let's see, x equals 3, 1, 2, 3. So that's this like dash line. Can I zoom in? On the right-hand side. So we as here, let me can I do it here? No. I'm gonna do a copy of this graph. Try to. I know we're kind of pressed for time. I'm watching the clock. I'm not gonna. I usually let you guys go if class gets out at like 10:50 in the next like 3 minutes. Okay, so I'm gonna take that quickly. She's so funny. If she hears any sound, she's like, okay. So as we approach 3, I think it said 3. Let me check one more time. As we approach 3 coming from the right, what happens to the y? Okay. So 3 is right here, because if this is a 7, this is 1, 2, 3, 4, 5, 6, 7, right? So then 3, that means we're talking about this guy here. So as we approach this red line coming from the right, what happens to our y value? It goes off way, way, way down there, right? So as we get closer to 3 coming from the right, y approaches negative infinity, right? So now let's hop back here. So as we approach 3 coming from the right, y goes to negative infinity. Hopefully that makes sense. Let me see the time. We got a solid 2 minutes. We're going to take advantage of these 2 minutes. Negative infinity. No, thanks. Enter. Let's go to the next one. Let's try one more. We got a solid 2 minutes. We're gonna take advantage of it. I'm gonna. I don't have time. We're about to wrap up. Use the graph of the rational function. As x approaches -4 from the right, what happens to our y value? So -4 is the vertical dash line on the left. Y goes to, as we approach -4 from the right, y goes to negative infinity. So that was a repeat, negative infinity. 1.5 minutes, that's okay. As x goes off to infinity, what happens to y? Okay. So as x goes off to the far right, the y value looks like it's getting closer and closer to 0, or in other words, the x-axis. So y goes to 0. I'm just gonna put 0. I'm giving you like, as far as these go, I'm giving like as many details as I can. I would definitely encourage you to link up with your classmates and definitely link up with the tutors as well, because you definitely want to get some different alternate perspectives. Because don't take my word for it. Even though I'm an expert, I definitely still make mistakes, right? And so I always want you. I don't want you to. I encourage you to ask questions and research and decide for yourself. I'm just trying to point you in a certain direction and get you on your own way. I'm trying to help everybody find their own way. What are the vertical asymptotes? Asymptotes. Yeah. What are the vertical asymptotes of the graph, right? So if we look at this graph, the vertical asymptotes occur when x is -4 and when x is +4. All right. So we're just going to put x equals -4, x equals +4. It says type an equation, use a comma to separate, answer as needed. Okay. So I'm going to say x equals -4, 4. I think that'll work. I'm pretty sure it's my notation. So let me put x equals. This is what they want. So I do have that is time. Let's do one more. Let's see, describe how the graph of this function. Okay, so if we're thinking transformations, the parent function is 1/x, and we put a -2 inside the parent function, right? So if we had f of x equals 1/x, then that -2 is like f of x -2, right? We put that -2 inside the function. So what that's gonna do, it should move it to the right. It's not see, the graph of f, the graph of f is the reciprocal function shifted, what, 2 units to the right. Shifted right, and then stretch vertically. There's no vertical stretch, but that's fine. We're going to go with C. So that's a recap on transformations. Identify the horizontal and vertical asymptotes. So horizontal, in that lecture that I posted, there's a test. There's a 3-pronged test that you got to do for the horizontal asymptote. One of them says that if the degree is based on the degree of the top and the bottom, the degree of the numerator in this case is 0 and the degree of the denominator is 1. So because the degree of the numerator is less than the degree of the denominator, this horizontal asymptote is going to be y equals 0. The vertical asymptote is going to be the x that makes the denominator 0, provided it's not 0. Again, I kind of go through these details in the lecture, but so I'm just gonna, I know this one is x equals 2 for the vertical, because that gives me some number over 0, so that means we have a vertical asymptote. And the horizontal is gonna be y equals 0, okay? So again, those details are in the lecture. We said y equals 0 and x equals a +2. The only one, okay, so it's either B or D, because that has a horizontal, both of those have a horizontal asymptote of y equals 0 and a vertical asymptote of x equals 2. But then we just need the right sections. I think it's B. Like for instance, if x were, when x is 4, we should get a positive result. If we plug in 4, we get a positive. I'm gonna go with D. I just kind of verified a few points really quickly in my mind. That's how I got that. Okay. I don't really want to keep you any longer than that. You guys were awesome. You know, if you're in here, that means I have questions. So let me see. We'll continue this discussion on Friday, same time, same place. But I do encourage you to go ahead and watch those lectures. It's a section 2.5. It was kind of long. The intent was for you to watch it over 2 days or whatever, two lectures and a little bit more, but watch it on your own, take notes as if you're in class. And I would definitely encourage you to come to Friday's class with questions. Anything that just wasn't clear, we can talk about it. Otherwise, if you just let me talk, it will kind of drone, right? So I don't really want to do that. I just want to try to encourage you to kind of practice and get your questions answered, okay? So we'll end the session here, and from one beautiful mind to another, enjoy the rest of your day. Take care, guys. Peace. I can hang around for a few minutes if you have more questions.
I have a question.
Okay. Let me stop the stream. Hang on. Let me stop the stream in case if it's anything. Stop the stream.